Hi guys, welcome back to another video, and in this video we're going to be writing the assembly generator for our compiler. This video is the third video of our compiler development series, and the previous two videos we had written the lexer and the parser respectively. So the current state of our compiler is that we would supply it our example.py file, and the compiler would use the lexer to tokenize our source code, and then it would use our parser to basically create the abstract syntax tree, and also to check whether our source code is consistent with the logic which we had defined in our CFG file. So if I just run my program again to see what's happening, so we do /pilot example.py. So basically we get all of our tokens and we get an indication which says that we have no syntax error and also the number of statements. So this is what our .py file looks like right now, and this is what our CFG file looks like. So in this video, one thing I want to mention is that I have switched over to Linux. I'm using my Kali Linux virtual machine. The reason for that is I actually don't know how to actually assemble and link assembly files in Windows. I think there are two ways to do it. You either use the GCC compiler or you use the Windows API, and I like neither of the two ways, so I'm going to be switching over to Linux. So currently my compiler would then only work on Linux operating systems. Maybe in the future we will make it compatible with Windows also, but that's something for the future. Right now I'm working on Linux, and in this video basically what I want to do is I want my example.py to look like something. We're going to be returning like 6, let's say, and we're going to be printing this is a string. So I want this to be compiled into its respective assembly. So for that I would need to first tokenize quotes and tokenize strings, because if I save this and if I run it, we'll get a lexer error because we haven't tokenized our quotes, neither have we tokenized our strings. So let's do it. So first I would have to write it over here, I believe. So we'll do token string and then we'll do token quotes, and in the type to string type we'll also define the logic for that. We'll do case token string, which should return a token string, and a case token quote, which should return token quotes. So I think this is good for now. So now we need to tokenize this, and the way we do it is we'll go to our switch case, and if I write a reference over here, we are doing print and then this is a string. So the semicolon is getting taken care of at the end, and the print is tokenized as a keyword, and the open and the close parenthesis is also getting tokenized. So we need to define a case for quote, and we need to then tokenize the quote, and then inside that we'd also need to tokenize string. So we do case quote, and inside what we'll do is we'll do tokens.pushback, and we will tokenize special, and inside this we will pass in token underscore quotes, and we copy this and we'll paste it, and in the between, in the middle of these two statements, we'll do tokens.pushback, and we will do tokenize string. This would basically tokenize our string, and it would return a token pointer. So this is how I want to proceed. So we need to define the tokenize string function, and I also want a break over here. Break, yeah. So we need to define our token string function. Let's just do it over here. So token pointer tokenize string. So what it would do is I think first we need to we create a string stream. So we'll do std string stream, call it buffer, just like we had did in the previous videos. And what we'll do is we'll do while the current is not equal to closing quotes, we will just inject the value into the buffer. I can never type properly. I normally don't type this horribly, so anyway, so we inject this value into the buffer, and then what we'll do is we'll create a token pointer. New token is equal to new token, and then the new token would have a type of token string, and the new token would have a value of basically we'll do buffer to str. Yeah, and over here, if we reach the end of the file without encountering the closing token, so this would give a missing quotes error. So if we do current is equal to end of file, we'll do std stdc out. We'll raise a lexer error because this error is originating from the lexer, and we'll do missing quotes, and we'll exit. Yeah, and also like in the actual pilot file there was some ambiguity regarding the fact if I was actually reading the way that we are reading our input file. There was some ambiguity regarding the fact that if we were actually reading the end of file character or not. So for now, what I'll do is this is our source code. So I'll just append an end of file at the end of it. I know there are better ways to do it, but this video is about creating a generator, so I think this is a quick fix, and this should work. It doesn't harm to have two end of file tokens at the end of our file, I believe. I could be wrong, but it definitely does harm if we have no end of file tokens. So anyways, so if our current would be end of file, we'll raise a missing quotes error, else we'll advance with the buffer, and then we do this. So let's save this, and now let's compile and run this. So we were getting a lexer error, unidentified symbol. We should not be getting this, I believe. Okay. So, okay, I think we are not returning from the tokenized string. There you go. We need to return the new node. So we'll just do return new node. Okay, it's new token. I'm sorry. Let's compile this again, and let's clear the screen first, and let's run it. So there you go. We are getting a syntax error because we have tokenized the string, but we haven't passed it. So that's why we're getting a syntax error. But if we look at our tokens, we see our print is a token keyword. If we open our example.py file, token keyword, token left bracket, quotes, token string, token quotes, token right bracket, and a token semicolon. So we are successfully tokenizing it. So now let's open our parser, and now let's parse the expression. So we are calling the parse keyword function, and the parse keyword function, and the parse keyword function was calling the parse print function if the value was print. So I had this simple code. This basically was I had like copied the code from the parse keyword, parse return function. But so let's remove everything. We'll write everything from scratch. So first what we'll do is we will proceed with our token keyword because we know that we are printing it. We don't need that anymore. And if I write down the syntax, we had print, we had left and right brackets, we had quotes, and inside this we had the string. And the semicolon is again taken care of. This is giving me, oh, this should be keyword, not print. So we first proceed with token left parenthesis. Let me just copy and paste this, and then we proceed with the token quotes, and then we would parse, and then we would again proceed with the token quotes, and then we would proceed with the right parenthesis. So now over here we need to define our new node. So we do ast node new node is equal to new AST node, and the new node's type would be node, not print, not int, but print, and the new node would have no substatements. The new node would have no value. It would have a child, and the child would be the thing we get after calling path string, and at the end we would return the new node. So now we define the path string function. So we'll do AST path string. I think we need to check first, right? Yeah. So if we do if current type is not equal to token string, what we'll do is we'll do std cout. We'll raise a parser error. We'll do cannot find a string. Okay, or we'll do the print statement does not have a string linked to it, and we'll do exit. Else what we'll do is we will create a new node. So we'll do AST node new node is equal to new AST node, and the new node would have a type of node. Okay, we don't have a node string right now, so I'll have to define it. Node string. We did have a node int because our program was only compatible with integers, but now we have to make it compatible with strings also. So node string, and the new node's value should be equal to the address of the current value. So we'll do current value, and we return the new node. Yeah, that should be working now. So if I save this, I think we should be getting no syntax error. I need to compile it. I hope there are no syntax errors now. There is a syntax error. Maybe it's because we are not proceeding. I think first I'm going to get rid of this. And I think it's because we're not proceeding inside the string function. Yeah. So currently our current pointer is pointing towards the token string. But since we have used it, we don't need it anymore. And we also need to move the pointer ahead. So we have to call the proceed function, and we need to pass in the token string. Let's save it. Let's clear the screen. Let's compile it, and let's hope it works. There you go, no syntax error. So now if I just remove this and save it, there should be a syntax error, missing quotes. Great. If I do this, there should be a syntax error, missing quotes. Great. And this should not be a syntax error. So I think we are now passing for our string. So I think we are now ready to get started with generating our assembly file. Before that, I would highly advise you to have a basic idea of assembly. I would obviously not explain you what assembly is in this video, because that's a different topic, and you could just look it up on YouTube. There are people which have more knowledge than me explaining what assembly is, so you should definitely check them out. But I'll definitely give you a gist of it. So I'll make a new directory, call it I don't know, ASM. So let's clear, and let's just do, okay, we are in this, right? So let's go to the ASM, and now let's create a test ASM file. So this is how we write comments basically. So just give me some space. So basically how a source code gets converted to an exe is there are three steps. We have the .py, which is our extension. It gets converted to .asm using a compiler. I'll just write it over here. So a compiler would convert a .py to .asm, and then an assembler would compile the .asm to .o, which is basically an object file. It could also do it to .obj, I believe, but .o. And then we have a linker which would convert the .o to the .exe or the .out file, depending on the operating system. So for our compiler, we're going to be using our own compiler. So we'll just do our own. The assembler which we're going to be using is NASM. NASM is a very popular assembler. And another assembler which you could use is the AS assembler. The syntax would be a bit different. NASM would follow the x86 style, I believe, and the AS would follow the GAS style. I'll get into it later. And for the linker, we're going to be using LD. So to explain what's the difference between the NASM syntax and the AS syntax, I'll just take an example. So for the NASM syntax, let's try to move 7 into the RBX register for both cases. So the way we do it in NASM is we just do simply move to the RBX the value 7, and that's it. But for the AS, basically the gas syntax, what we do is we have to define the size of the move operation. So it could be either move L or move B. So if we do move L, and then generally in assembly we have the destination first, then we have comma source. But over here we have first the source, then destination, and any immediate value should be prefixed with $, and any register name should be prefixed with %. So in the gas syntax we have move L $7, and we move this value to the RBX register. So this is basically the same instruction in two different syntaxes. So this is why I'm using NASM, because NASM is a bit easier to read. Even though AS syntax looks much cooler, but NASM is what we are going to be using. So that being said, let's just try to do some basic stuff with assembly. So an assembly code has two sections basically. The first is the text section, and the second is the data section. So the data section would actually hold all our strings, and our text section would hold the actual code. So let's define our text section for let's just try to return something. So we'll do section.text, and we would define a start label, and we need to make this label global. So we'll do global start, and then after this what we'll do is we'll move the value 60 into the RX register. The 60 is basically the operation. 60 is basically the code for invoking write operation. So this is how basically we interact with the Linux kernel. We use operation codes. So 60 is the operation code for writing stuff onto the screen, and then we move to the RDI register the exit code. Basically, I want to put a comma over here. So let's say we want to exit 7. Let's say we want to return 7. So we move to the RDI register the value 7, and then we make a syscall. So if we assemble this and link this and run this, it should return 7. So the way we do it is we do nasm-f elf64, we pass in test.asm, and we do ld. The output name should be test, and the input file should be test.o. And if we run it, so it didn't do anything because we are just returning 7. So the way we check the value which was returned last is we do echo $? So we get 7. There you go. So if our program looked something like return 7, this is exactly the source code which I want for this corresponding .py file. And in Windows, to check the exit code or the return code of the last executed program, you do echo percentage error level, I believe. Error level. Can't type properly. Error level. This is how you do it in Windows. So you can check it out maybe. I don't know. So this is how you do stuff in assembly. So now let's create our generator file. So we'll call it generator.hpp. We'll do the if not defined stuff. Even though I can do pragma, I like this much better. We'll do define. And now let's write the generator class. What's the spelling? Generator. This has to be in small. Yeah. So we create the generator constructor first. So the way I want to do it is similar to the way we had done the parsing. So we created a constructor and then we called that constructor. So I'm going to be doing the same thing. We will create a constructor for our generator and we'll call it in our main pilot file. So our generator, what it would do is it would take in the root node, I believe. Yeah, so I need to include this first. So I'll just do include. We need to include lexer. Let's include lexer. I don't think we need the lexer. We just need the parser. So we'll do parser because we need the AST node values actually. So actually our AST node value could have been in a different file so that we don't have to include the entire parser.hpp, but it's okay for now. So we include the parser. So generator would actually in the public section. So in the public section, we'll have the constructor class, which would actually accept an AST node pointer to the root. And in the private section, we'll have first of all we will have we will save a reference to the root. So what we'll do is AST node pointer, call it AST root. And what else do we need? We have a root pointer, and I think we need to include an output file stream. So we'll do include fstream, and we'll do string output file stream, and we'll call it assembly file. And yeah, and I think I also want to pass in the name of my file. Like if it's example.py, we want to do example.py.asm. So that would be a string, and we'll just do a file name. So what we'll do then is we'll first link our root to the root which we have passed, and then we will create our assembly file by like this. So we'll do assembly.open, we'll do file name, and we'll concatenate .asm at the end. So this should work, I believe. So now let's save this and let's include this in our generator file. Sorry, in our pilot file. And over here, we'll just create the generator class. So we'll do generator, and we'll pass in the root, and we'll pass in argv1, and let's just see what's happening. So if I compile and run this, we should have an example.py.asm file which should be empty. Let's compile this. Okay, we are in the wrong directory, that's why. Let's compile this and now let's run it. Let's see what's happening. Okay, I'll just do it manually. So we are getting an example.py.asm which is empty for now. So Now let's go back to our generator file. So we'll create a generate function which would be void because we would be writing out. So I don't, yeah, it would be a void function. So we'll do void generate. And now actually I want two string streams, basically a string stream for our, like if I open my test.asm file, I want a string stream for our text section, and I also want a string stream for our data section. So it would be over here. So this should be above, and this should be above, and this should be below. So we would need two streams for that. So let's just I don't want so many files to be open. I'll just close this. I'll just close the Lexer file, and I'll close the pilot file. So what we'll do is, I think we have to declare them in the private scope first. So we'll have a string stream, and this would be section. What do we have first? We have the data, then we have the text. So section data, and then we have a string stream section text. And actually, in the generate, what I want to do is at the end we will have our code over here, but at the end what we'll do is we'll call a function called as write sections. Over here we will basically be writing to the section data or the section text stream respectively, and in the write sections function we would basically write the value of the section data and section text into our actual assembly file. So we will do write sections. We will declare the function. Let's declare it over here. We will do void write sections, and then what we'll do is we will do assembly file, and we'll first write the section data into it, and then we would write the, it shouldn't give me an error for some reason. Okay, okay, so it's still giving me an error for some reason. Do we need to convert it to string? Okay, let's just see what's happening. So section text. So we need to write the section data and the section text into the assembly file. I think we need to convert it to string. So let's do .str. It's working now. Wait. And then we would just close. We'll do close. I think this should be working. And in the generate functions, what we'll do is we will push the boilerplate code into the respective sections. So in the section data, what we'll push is we'll push in section dot data and a dot and a new line. Let's do two new lines. And the section text, what we'll do is we will push in dot text, and then we'll do global underscore start, and yeah, I think this should be working. So if I just compile and run this again, I think we should have our boilerplate code. So if I open this, I think we aren't calling the okay, we aren't calling the generate function, that's why. So we open our pilot file, we'll do generator dot generate. Let's save this, let's compile this, and I'll just keep it open. So now if I run this, there you go. So we have this over here. So now let's start generating the return stuff. So first we write the code to generate the return assembly. So I think I'll just cut this and we go back to our generator. So what we'll do in the generator is we will loop over. Actually, it's better if I write down first. So AST node pointer, call it current, in root, and okay, it's AST root, I believe. AST root and substatements. So for we loop over every substatements and the value would be in the current. So we would switch on the current, I believe, yeah. And for the case of node return, we would actually call the generate return function, and whatever data is being generated by that function, we will append that to section text. So this is what I want to do, and then we'll break. And we aren't switching on the current. I think we are switching on the current type. And we need to define the generate return function. And yeah, I think we would have a default case, which would be, I think we'll just print something. Let's do stdcout unrecognized node, and I think we would now need to write the node to string function. So we'll do node to string. We would need to define it, but we'll just do current and type, and then we would break from here. So we would now need to, let's close our test.asm file, let's save it, and let's open our parser. So we would need to define our node to string file function, sorry. Node to string, it would take an enum node type and call it type, and we'll just switch on the, I don't know why VS Code comes up with this stuff, but okay, we'll just switch on the type. And in the case of node root, we'll just return node root 1 2 3 4 5 6 1 2 3 4 5 6. And for the case of variable, we will return variable. For the case of return, we will return node return. For the case of print, we would return print, and for the case of int, we will return int, and for the case of token, okay, what's this? And for the case of string, sorry, we will return string, and we'll have a default case here also, in which we'll return unrecognized token node. I keep interchanging node and token, nodes and tokens. So let's save this. So this function is defined now. So we need to define the generate return function. So our generate return function should return a string, I believe. Yeah. So we'll do std string generate return, and I think we need to pass in the current, because else we wouldn't have a reference to it. And over here we'll accept a node, ast node pointer, we'll call it statement, and we'll also make a check over here. So if the statement has no after in a return node we should have integer linked to it, or we should have at least something linked to it. So if the current, or if the statement child and value does not exist, what we'll do is std cout. I think this error would be caught by the parser, but I think we are just doing it for the sake of doing it. So we'll do a generation error. The return statement has no integer, no value linked to it, and we will then simply exit. Else what we'll do is we will so this was our code. Let's just close this. Let's open our test.asm file. So we have to write this into our section text. So we'll I think we don't need to do it. What we need to do is we'll define a temporary buffer, temporary string stream, call it as buffer, and into the buffer we'll write, let's call it code buffer. And into the code buffer we'll write first move I think we need to have a /n over here. So we'll move the exit code is 60, I believe, the system code. So we'll move 60 to the RAX. Let's just do it like this, and to the code buffer. Then we'll move RDI, I believe. So we'll move to RDI the value which we get after dereferencing the statement child and value, and then we will append a syscall. Then we'll return code buffer to str. So I think we should be getting the assembly which we need to return. So let's compile and see what's happening. So let's open our ASM file over here. Let's compile it. We have our example.py over here. Let's open this over here. So our example.py is returning 7. So if we run this, hopefully it should work. So there you go. It's kind of working. It is working, yeah. So I want a space over here, and this should also be on a new line. So I'll just add another space over here, and this should I'll just do it over here. So now if I compile and run it again, if I compile it and run it, there you go. So we have the corresponding assembly. So if I change this into return 141, and if I save this, and if I run it again, we would have 141. So there you go. So we have this working. So now I think let's get all of the stuff like assemble and link this. So we'll open our pilot file over here, and we now need to first assemble it. So we'll use the system, and we want to pass in nasm-f and blah blah blah. So what we'll do is we'll make use of a string stream again, call it assembler instruction, and to the assembler instruction we'll first push nasm-f elf64, and the code for this was we just pass in the name. Yeah, so we'll just append we'll just do argv1, and then we will append a .asm at the end. And then what we'll do is we'll run this instruction, we'll convert it to string, and we need to convert this. See, this takes in a constant character pointer, so we need to convert it to a constant string. So we'll use this function. So this should be working. Why is it giving me an error over here? You know what? Actually, our argv is example.py. We would need the word example itself later. So what we'll do is we'll just create a string over here, std string. We'll do it file name without extension, and this would be argv1. And then what we'll do is we will call the pop back function on it twice. So it would be example.py. So if we pop 3 times, we'll get example. So that's what we want. I know there are better ways to do it, but this is what I want to do right now. So we'll append the file name without extension, and we'll do a .py.asm. So this should be working now. And if I do this, now we are left with the linking. So we'll define another string stream. We'll do string stream linker instruction. Linker instruction, and then we'll do ld, and the output. Okay, 1 second. ld, and the output would be file name without extension, and then we need to supply in, we need to put a space, and then we need to do file name. Okay, not this, we need to, okay, I'll just remove this. And we'll do a .o over here. I think it's .py.o. And then we will execute this. So system linker instruction to convert this to a string, and then we convert the string to a constant character pointer, and we run this on the system. Let's see how terrible our code is. So let's compile it, and now let's run this, and we should have a .example. If I run this, if I check the return type, we are getting 141, and there you go, our program is working. So we have the very simple compiler which does absolutely nothing. It just returns an exit code for now. So if we do return 7 and save this, and if we do pilot example.py and we run the example which it generates, and then we check the exit code, we get 7. So we have at least something. So we are getting the return code. So now we need to write the logic for printing stuff, and once we are done with that, I think we'll wrap up this video. In the next video, I'll show you how to make variables and stuff. We'll link variables with integers and strings, and then in the next video we'll do while loop, and we'll come up with if else, and we'll add comments. Maybe we can add comments in this video itself, but I don't know. Right now we want to print strings onto the screen. So I'll just open the test ASM again. So what I'll do is I'll just move to this directory, and the way we do print strings is we first define our string over here. So we could call it like we are saving the reference of the string. So the way we do it is you can name it anything. I would just want to name it like string reference and then 1. Because this would be the first string, and then over here we do define by I don't know, hello there, and then we would need to get the length of this. So the way we do it is we have a similar naming convention, sref1 underscore L for length. That should be equal to equ dollar. Dollar basically means the current address minus the address of sref1. So this would give me the length of basically the length of our string. So it's very important to get the length of our string, because we also would need to supply the length of the number of bytes which we want to print. So over here what we'll do is this is the way we return stuff. The way we print is basically we move 1 to the RX register, which is basically invoking the system call for write. So we move to the RX register the value 1, and then we move to the RDI register the value 1, and then we move to the RSI register the address of our string sref1, and then we move to the RDX register the length or the number of bytes which we want to print. So that is sref1 underscore L, and then we invoke a syscall. So if we run this, let's just run this in the same thing in one line, and if we do this, there you go, we are getting a hello there. And this is red because we are returning 7. Let's return 0, and let's run this, compile it, and let's clear the screen first. Let's run this. So we are getting a hello there. So this is how we would print stuff in our assembly. So what we'll do is let's just go back to our generator, and in the generator we are switching on the current type. So if we get a node print, we need to write a case for that. Node print, we would actually, the thing is, I also want to talk about something. If we want to print a string which is already defined in this section, we don't need to obviously define it again. But if we want to print another string, you would need to first define it in the data section. Then we would need to write this corresponding assembly code in the text section. So we don't actually know whether we are actually writing only to the text section, or we are writing both to the data section or the text section. It actually depends upon the string. So we will actually not return anything. We'll just call the generate print function, and over there we'll just correspondingly work with stuff. So what we'll do is we'll just do generate print, and we'll break. Now I need to define the generate print function. It would be a void function. I actually don't like void functions that much, but anyways, so generate print, and I think I need to take in a reference to the statement. And I haven't passed this over here, I believe. So we'll just pass in the current. So now what I need to do is first if I go back to my generate return, we were checking for a value, and I think we need to do the same over here. So we'll just copy it and we'll paste it over here, but in the error message what we'll print is generation error. The print statement has no string linked to it. Else what we'll do is first we would need to check whether we already have the string defined in our data section or not, right? So we would need to have basically the way we are defining this is we have sref1, and then for the next string we'll have sref2. So we need to have some kind of a counter And you know, we could start with 0 itself, so it would be like the index of an array. So I'll do that. So in the private section, we'll do int string reference counter, and we would also need a vector of string pointers, which would actually point to all the strings which we have stored. Yeah, I think that's how we'll do it. So std vector std string pointer, we'll call it string references. I think I spelled it right, references. The spelling of reference over here is wrong. The string reference. String reference. Okay, yeah. Have we included vector? We haven't. So we include vector, and over here, I want to drink some water first. My neck is very thirsty. So what we do is we define int reference number first. This is the way I want to do it. So basically there would be a function which would take in the value, and it would check whether this value is present inside the string of vectors or not. If it is, it would return the reference number, else it would return -1. So if it is -1, we'll append the value. And also in the constructor, I want to initialize this. In the constructor, I'll just do string reference counter is equal to 0. Or I think I'll do it in the generator function. It makes more sense for this to be here. Yeah. So in the reference int reference number, we have a semicolon over here, and this should be we'll call it lookup, and we'll pass in the statement. We'll pass in the child, and we'll pass in the value. Okay, I don't think we need to do this. We need to define an integer lookup. Int lookup, which would take in a string pointer, call it data, and we will loop through every. Let's define a counter which should be equal to 0, and for we are saving the reference, right? So for std string pointer temp in std vector. Okay, no, we don't need to do it. It was string references, I believe. String references. So if the value we get after dereferencing temp is equal to the value of data, then we'll return the counter, and we will increment the counter else, and at the end we'll just return -1 if we didn't find it. Yeah, so if okay, it should be over here. So if our so this should be here, yeah, and if the reference number is equal to -1, what we'll do is we'll do string reference. Okay, so initially the value of the reference counter is 0, and after we are appending it, we'll append it over here, and then we will increase the value of the counter, right? 1 second, yeah, we do this, and then over here the reference number would then be equal to the string reference the string reference counter, and then we will append the address of statement child value into our vectors. So we'll do string reference, string, I never type properly, string references dot pushback, and we'll just append the statement child and value, and we get our reference number also. And actually we cannot just simply append this. That's very stupid of me. We need to define it in our data section. So what we'll do is we will call it define function. Okay, we'll do define, we'll do section, I think section data, yeah. So we'll call it section data define, and we will define this entire thing. So basically this function will take in this pointer, it will dereference this, and it will then define the string. So we would also need to pass in the reference number, I believe. Yeah. So another void function. I am not very fond of void functions. I actually hate them. I like when functions return something. So it's very odd for me to write void function. But anyway, so we'll do void. It was section data define. We were taking a string pointer. We'll call it a new entry, and int, we'll just call it reference number. And what we'll do then is we will in the section data, what we'll do is okay, if I just open my test.asm in the section data, I'll first do sref and then the reference number, and then a new line, and okay, a colon, then a new line. So we'll have sref. Okay, why is this giving me an error? So if I just do this, should this work? I don't know how this works, but this seems to be working now. So, and then over here we'll just paste this. Yeah. So sref 1 and then a colon. Let's just add some space and then a colon, and then in the new line we'll define the byte hello there. So we'll do db space, and within quotes we'll write hello there. Yeah. So then again in the section data we'll do db, then a space. I think we need a quote over here, and then we would dereference our new entry, and then we would append this with another quote and a new line. I hope this works. So db quote new entry, then a quote, then a new line, and then to the section data we'll write okay, we need to generate this, right? Okay. Wow, this is gonna be terrible. sref and then the reference number, sref1, and then we'll also push an underscore. I bet this is looking very bad right now. I just want to get this done with. We'll optimize it properly in the future videos. I just want to get this over with. I want this to be working. So underscore L, then we do this, and then we do EQU $-, and then we now need to do okay, sref, and then we need to write the reference number again. And I think I'll just append that with a new line. This doesn't work for some reason, so I'll just do it over here. I'll just write in 2 new lines. I want to do it like this, not like this. Yeah. So this should define our string. Now once this is done, actually I don't want to, the next time that we run this, I don't want to run this because I want to avoid segmentation faults. So what I'll do is, okay, what the hell, I'll just comment this out, and I just want to see what's the assembly that's being generated. So anyways, so once this is done, we just want to write what do we want to write? We want to write this. So we want to move one to the RAX, one to the RDI, and then we want to do this. Okay. So we do the section text, right? Let me just make sure. The section text, we'll move to the RAX and the RDI. I need to make sure RAX and RDI. Move to the RAX, the value 1. We move to the RDI. Okay, let's not do it like this. Let's do it in separate lines. So it's kind of more readable. So we move to the RDI, the value 1. And then we move to the RSI, sref. Let me just open this. Sref and the reference number. And then we again write to the text section. We first do a new line and then we move to the RDX, sref, okay, reference number. 1 second. And then we do an underscore and L. This is again giving me an error. I don't know why, but so we'll just take it out from here and we'll just do section text and we write, okay, we write it like this, L, and after this we would just invoke the syscall. And we will do this twice. I think it should be working now. Let's save it. Let's have our example.py.asm. Let's compile it. We are in the wrong directory. So let's do G++. Now let's compile this. There shouldn't be any difference right now because this looks the same. But if we define a print hello there, we should have the code for it. I hope so. Hello there, semicolon, and let's keep this open. And there you go. It's working. Okay, it isn't. Is it working? Okay, we aren't getting the value of sref, like this had to be suffixed with the counter, right? Apart from that, I believe everything else is working. I don't know why that is happening. Do we need to convert it to string? what do we do? Dot to string. How do we convert this to string? Do we call in this constructor? Why is this happening? Okay, let me just do. Oh, this has to be in quotes. So yeah. Do we do 1 comma this? Okay, it's working now. But I don't know why that happened, but let's just see. Reference number should be 0. And okay, this is a weird stuff. Oh, okay, this is being treated as the null character. If we start with 1, okay, how do we convert an integer to string? That's probably the silliest thing I've asked, but I'll just look it up on Google 1 second on my phone. We should have a dot, like a toString function. I don't know why can't we use it. Okay, we should have this toString. Oh, there you go. Should this work? I really hope so. Oh, we compile this, we run this, and there you go, it's working great. So we need to do this everywhere now. Great. And I need to remove this and just copy it over here. I'll just get rid of this and okay, and over here also we'll do the same. So we should have our, okay, we need to compile it first, and if I open this now, I think it's, yeah, I think it's working now. So now let's try to add another string. Let's do print, this is another string. Let's save this, and now if we run it again, we don't need to compile it. Great. And we are calling for that too. Great, it's working. I hope so, it's working. Could be premature happiness, I don't know, but like if we do another print hello there, we should not add anything to the data section because this is already defined. So this is already defined, so we should not have an S reference too. Let's see, there you go, and we should be but calling it over here. Great. So I'm very happy with this, so let's just get rid of this. Let's save this, let's clear this, and now let's make some changes in the pilot file. Let's just like run this. So assemble and link this, not run this. So I'll compile it again, and let's just run it. And if I do dot example, what should we have? Let's hope we have a hello there. There you go, we have a hello there. So we have a working compiler and it's returning 7 right now. So let's return 0 and let's run it again. We need to compile it. Let's run it again. There you go, hello there, and the return type is 0. Great. So if I do print, this is, one second. This is another statement. And print, let's again print hello there. So if I do this and if I run it, there you go, it's working. If I add a new line over here, this would raise some issues, I believe. Or would it? Let's just see what's happening. It's actually very interesting to see. Okay, we are treating this as a character. But anyways, so what we could do is we could make some changes to manually append a new line at the end of it. But it's good for now. There you go. So we have our very simple compiler which is printing something onto the screen. And you know, actually I don't want this to be so verbose. We are printing like a million stuff. I don't want to print this. I don't want to print. Let's just comment this out. And I don't want to do this. Let's save this. Let's compile and see what's happening. I'm gonna make some more changes. So I'll compile it once. I'll do compiling this file, and yeah, now let's do g++ this. Let's clear the screen. Let's do pilot example.py. Okay, I don't need the source code anymore. We just need like this is the source code. We don't need that. And we don't need the end thing. So now let's compile this again. Let's clear it. Let's compile this. And now let's have our example.py open. And now let's just open this here. How do we open this simultaneously? Is there a way to do it? Like I want to open, there you go. It would be better if this was here and this was there. One second. Yeah. Let's close this and let's just collapse all of this. There you go. So we have our .py file and we have the corresponding assembly which is being generated. So let's just return 0. Let's save it. And we'll do pilot example.py and we'll just run example. There you go. So this is what's happening. And you know what? We'll just do, and we'll clear the screen and then we'll run it. Okay, it's on CLS, it's clear. So there you go. So the last return type was 0. If we return 141, we should be getting, there you go, our assembly has changed, and then the return type should be 141. Now let's, for the sake of it, let's return 7, and now let's print hello, hello there. Let's save it. Let's clear the screen. Let's run it again. Hello there. So this is our assembly which is being generated, and this is our output. So I think that's it for this video, guys. I'll commit this entire update to my GitHub. You can check it out. And I really want to make this compatible with Windows. If any of you guys know how to do it, please tell me. I actually wasted an entire day actually trying to run this on Windows, I was like, maybe I don't know enough. I think that's the reason. I do not have a lot of information about this. So if you have the knowledge about how to run this on Windows, please tell me. Run this on Windows without using the Windows API or the GCC compiler. And in the next video, we will define variables. We will define printing integers. We'll link I think I went over this, but I'll just went over this again. We will define variables. We will define linking variables with strings and ints, and then we will add comments. Adding comments to our language would be very easy. So we'll do that, and I think after that, in the next video, we will add while loop, not for loop. For loop is a bit tricky. We'll add while loops, and we'll try to do if else and stuff. And then in the next video, so I'm planning way for the future. Maybe we won't do it, but most probably we'll do it. So in that video, in the next video, I'll try to redefine the entire syntax. So this looks very like C style, right? It does look very similar to C. I don't want this to look very similar to C. I'll convert the syntax to be very, very easily readable. So we'll do that in the future video, and that's going to be very exciting. But that's it for this video, guys. Thanks for watching. If you have any kind of feedback, please comment me in the comment section. Yeah, thanks for watching. Bye bye.